and gentlemen, a warm greeting to you all. We are delighted to welcome you to the 31st inaugural lecture of the prestigious Inaugural Lecture Series organized by the Faculty of Graduate Studies at the University of Moratuwa. To formally inaugurate today's proceedings, it is with great honor that I invite Professor Yasamika Sadhanayaka to introduce our professor for the day.
Good afternoon to everyone. It is an honor and privilege for me to introduce Professor Waidyasekara today. I knew her since year 1999, first as first year undergraduates, 2 years junior to me. But more than that, we used to travel from Kottayam to university daily by bus in the morning. So we use that opportunity to share not only our knowledge but also to do a little bit of gossiping. Since then, we supported each other during more than last 20 years, shared good and bad times, argued, laughed, and we were good friends. So it is my pleasure to introduce Professor Waidyasekara today. Chartered Quantity Surveyor Professor Waidyasekara is a distinguished academic, researcher and a professor in quantity surveying, currently holding the position of Head Department of Building Economics, Faculty of Architecture, University of Moratuwa. She earned her Bachelor of Science Honours degree in Quantity Surveying in 2002, Master of Science in Research in 2006, and Doctor of Philosophy in the Built Environment in 2016 from the University of Moratuwa, Sri Lanka. Professor Waidyasekara began her journey with the Department of Building Economics in 2005 as a lecturer on contract basis. She was appointed as a lecturer probationary in 2008, marking the start of her distinguished academic career. Her dedication and expertise were recognized through successive promotions, first to senior lecturer grade 2 in 2016 and subsequently to senior lecturer grade 1 in 2019. In 2022, she achieved the esteemed position of Professor in Quantity Surveying on merit, a testament to her outstanding contribution to the field and the department. Professor Waidyasekara is a well-recognized professional in the field. She is a Chartered Quantity Surveyor, a corporate member of the Institute of Quantity Surveyors Sri Lanka since 2009, a corporate member of Australian Institute of Quantity Surveyors since 2010, and became a certified quantity surveyor at K.G.A.S since 2020. She is also a council member of the Australian Institute of Quantity Surveyors Sri Lankan chapter since 2015. During her remarkable 19 years of academic career, Professor Waidyasekara has made immense and inevitable contribution to the development of the Department of Building Economics. Notably, she served for over 8 years as the undergraduate coordinator for the BSc Honours in Quantity Surveying degree program, demonstrating her commitment to the academic excellence and program management. Her dedication extends beyond teaching and research, encompassing significant roles in student engagement and welfare. She served as a senior treasurer of the Building Economics Student Society from 2018 to 2022, fostering a vibrant and supportive student community. Since 2018, she has also been serving as the student counselor for the Faculty of Architecture, providing steadfast guidance and mentorship, underscoring her unwavering commitment to the students' holistic development. With over 19 years of teaching and research experience, she has contributed extensively to academia and industry, with more than 100 publications in reputed index journals and conferences. Her impactful research has been recognized with numerous awards, and she has served as both principal and co-investigator on a range of local and international collaborative projects. Since 2018, Prof. Waidyasekara has co-authored the Scientific Committee for the World Construction Symposium, further demonstrating her leadership in the academic community. She is also an active member of various international scientific committees, serves as a reviewer for several experts. She is an associate editor of the Built Environment Project and Asset Management Journal, published by Emerald since 2021. Her research spans a broad array of critical topics, including sustainable construction, green building practices, renewable energy, modular construction, and innovative construction technologies. Her contribution to the field for these fields have rewarded with several best paper awards at international conferences, further highlighting the relevance and the impact of her research. Professor Waidyasekara's excellence in research has been consistently recognized by University of Morocco, where she has received Outstanding Research Performance Award every consecutive year since 2011. At the national level, Professor Waidyasekara has rendered consultancy services for high-profile projects in both state and non-state organizations, showcasing her expertise in quantity surveying. She has significantly contributed to the advancement of the quantity surveying profession in Sri Lanka through her active roles in the Board of Quantity Surveying Education and Training at the K.G.A.S and various committees under the Construction Industry Development Authority. At the University of Morocco, Prof. Waidyasekara has provided inevitable services by serving as the chairman, member, and client representative of the technical evaluation committees for over 30 projects, reflecting her dedication to the institutional development. I have honor and privilege of introducing Professor Inaugural Waidyasekara to this inaugural lecture today. Thank you.
I sincerely appreciate Dean, Faculty of Architecture, Professor Yasamika Santanalika, for the kind introduction about me. Good afternoon, everyone. It's my great pleasure to deliver today's inaugural lecture. And I sincerely thank the Vice Chancellor, University of Moratuwa, Professor Naranjan Gunawardena, and Dean, Faculty of Graduate Studies, Professor Ruan Gopura, for giving me this opportunity. So I warmly welcome everyone present here, especially including my loving family of building economics and those joining us online. Before moving to the presentation, I would like to take a few minutes to share my journey at the University of Moratuwa and express my sincere gratitude to those who have helped me to reach the position today I'm in. First and foremost, I'm deeply grateful to C.W.W. Kannangara, the father of free education in Sri Lanka. His contribution enabled me to pursue my education without financial barriers. And I am now honored to have the opportunity to give back to my country. I entered the University of Moratuwa to pursue my bachelor's degree, BSc Honours in Quantity Survey. Subsequently, I obtained my MSc in 2006 and PhD in 2016 from same university. I take immense pride in being a product of the University of Moratuwa, a place where I have dedicated more than half of my life to learning, teaching, and contributing to its growth and excellence. So these slides outline my academic and professional qualification, highlighting my key milestone in my career. I began my academic journey in 2003 as a research assistant in Civil Engineering Department under the supervision of current Vice Chancellor, sir. After completing my bachelor's degree, I joined there, and I was also awarded the ADB scholarship to pursue the MSc program. So I would like to acknowledge two mentors who profoundly shaped my academic career path. After completing my MSc, I initially intended to enter the industry. However, Professor Asoka Pereira inspired me the confidence to pursue academic career, and Professor Ramesh Dean provided me the opportunity to join the Department of Building Economics as a junior lecturer in 2005. So 17 years later, I am honored to serve as the head of the department of this department. So this is a privilege that I hold close to my heart. As mentioned previously, I would like to express my sincere gratitude to special people in my life who have helped me to reach the position I'm in today. First and foremost, I would like to take this opportunity to express my heartfelt gratitude to my beloved parents, who are my greatest strength, and to my siblings and in-laws for their unwavering support, motivation, and encouragement throughout my life. Then I'm deeply thankful to my loving husband, Nadine. Currently, he's overseas, and my son, Netu, for their endless love, patience, sacrifice, commitment, and understanding. Their belief in me and the freedom they have given me to pursue my dreams have been invaluable. I have also felt blessed by their presence in my life. I'm also deeply grateful to all my teachers, including my supervisors, colleagues, the building economics family, friends, students, and everyone who has supported me countless ways along my journey to reach this position. I apologize for not mentioning each of you by name. Now I will move on to my presentation. My research interests include sustainable construction, green buildings, waste management, circular economy, and innovative technologies in construction. Today, I have chosen the topic Sustainable Material Selection in Construction through the Circular Economy Principles. So I would say that although the circular economy has made significant progress in recent years, advance in sustainability, its implementation in the construction industry, it remains in its infancy, especially developing countries such as Sri Lanka. However, with the growing concerns over resource efficiency, waste reduction, then environmental impact, the research on circular economy in construction has gained considerable attention in recent times. So now we'll move on to what is construction industry. The construction industry is a unique and a vital sector for any country. In Sri Lanka, the construction industry plays a crucial role in driving economic development of contributing to infrastructure development, then the urbanization, employment generation. However, the construction industry faces numerous issues. Resource constraint, regulatory demands, and sustainability concerns. Mainly, among these, excessive consumptions of raw material, waste generation, then the pollution, carbon emission are the most pressing issues. Ultimately, it will impact the ecosystem and the built environment. What is built environment? The built environment is a man-made environment which includes infrastructure, buildings, landscaping, urban designing, urban planning. Some statistics shows that the construction industry consumes more than 30% of material, 40% of energy, and 30% of water and generate 40% of waste, contribute 23% to air pollution, and accounts more than 30% of carbon emission, all of which are ultimately attributed to the built environment. So, accordingly, the construction industry has a significant impact on the environment. So it is evident that we need sustainable solution to overcome these issues effectively. Let's see then what is sustainability and sustainable practices in construction. The most well-known and widely accepted definition of sustainability comes from the Brundtland Commission report in 1987. Accordingly, the sustainability is defined as development that meets the needs of the present generation without compromising the ability of future generation to meet their own needs. So accordingly, to create a sustainable future, we are each responsible for our individual activities. Social, environmental, economic dimensions are identified as triple bottom lines of sustainability and also known as 3Ps: people, planet, and profit. So in the construction industry, to sustain this triple bottom line combined with technological advancement emphasize the balanced approach to enhance sustainability efforts. Sustainability in construction, often involves effective use of resources like energy, water, material, reducing waste, pollution, and protect the built environment. Although extensive research has been conducted on sustainable practices in construction industry, the main challenge lies in their implementation. So I would like to share 2 findings from my research work. So this is I did for my PhD. So the topic was the sustainable use of water on construction site. Even you believe or not, the water is a neglected natural resource in the construction industry, right? And 100% potable water, or we call it as a drinking water or pipe-borne water, that used for both direct and indirect construction activities. So my study, I analyzed both water using activities as well as water wasting activities. So the study revealed that around 75% of water is used for indirect construction activities, as well as the water wasting activities also high in indirect construction activities. So mainly due to site cabins and sanitation. The main causes to identify as work attitude, worker behavior, and they feel that the water is still free of charge. They don't have idea about the future water dilemma. And lack of commitment, poor monitoring and supervision, less attention. So I don't like to put a blame to only the construction employees, right? Workers at construction site. So this is beyond the site level. So authorities have a responsibility to practice sustainable practices at construction site. So my study, I identify water efficiency measures. Based on that, I developed 3R, 6R and extended water hierarchy. Further, I have developed the comprehensive guideline to develop the mobile app, especially water sustainable use of water on construction site. Based on that, I have published more than 10 index journals and conference papers. If anyone interests, you can go through those papers. The another study I would like to share: impact of environmental behavior of construction employees on environmental consequences at construction site. So this is the accepted, the popular behavioral theory, that is norm activation model. So NAM used to understand the predict human behavior in the context of pro-environmental action. To analyze the study, we used structural equation modeling. And then we found that personal norms significantly and positively affect environmental behavior, even in terms of dust, noise, water, waste. So this study proved the importance of construction employees' behavior in achieving sustainable practices. Coming back to my previous slide. So in recent years, sustainable concepts like circular economy, design for reconstruction, life cycle assessment, green economy, modular construction have played a significant role in the construction industry, helping to achieve sustainable objectives. Now, the topic I'm talking about today, the sustainable materials. So it is evident that construction materials plays a crucial role in the industry. The demand for those materials increasing daily. However, their production, transportation, use, and dispose have the significant impact on the environment. For example, here some negative impacts due to extraction of materials can be identified as noise pollution, air pollution, water pollution, chemical emission, release of CO2, damage to ecosystem, energy use. So then we need innovative, efficient, sustainable materials, and eco-friendly construction practices are needed. So what does it mean, sustainable materials? So sustainable materials are low embedded energy, cost-effective, and environmental friendly materials. So for that, we need optimum use of materials and reduction in waste, carbon emission during construction and operation is significant. However, some researchers have identified that building material consumption rate of building could exceed the regenerate rate of resources. So when we revisit sustainability definition, we all have a responsibility now. So it is required to reduce the demand for new materials to be provided in the future. How? To address these issues, we have identified certain strategies. Among circular economy has emerged recent years. So circular economy focuses on resource efficiency, aims to reduce waste, contributing to protection of natural resources and promoting the sustainable practices in construction. What is then circular economy? Researchers have identified that paradigm shift from linear economy to circular economy is inevitable with conserving materials. As you all know, the linear economy model is a common in the construction sector, which typically consider take, make, used, dispose approach. And also the linear model associated with mass production and resources consumption without considering the physical limit of resources. The concept of circular economy evolved gradually, shaped by ideas from various scholars and school of thoughts. According to environment economists K.G.A.S and Turner, circular economy is described as a system in which material are kept in use as long as possible and waste is designed out of the process. There are many definitions of circular economy in literature. One of the most widely recognized definition comes from the Allen MacArthur Foundation. Accordingly, the circular economy is one that is restorative and regenerative by design. It aims to create products, component, material at their highest utility and value at all times, while distinguishing between technical and biological cycles. So according to this definition, resources do not end up as recyclable. Instead of, products are designed to last through several life cycles. Simply, the linear economy creates waste after used. The circular economy, materials are collected and reused after each use. So this slide illustrates what is technical and biological cycle. And this is also known as butterfly diagram. In a circular economy, waste is eliminated by design. So in the biological cycle is for product intended for consumption, where in technical cycle is for products used in production or services. The consumption occurs only in a biological cycle, where in the technical cycle focuses on recovering and restoring product, component, and material through strategies like reuse, repair, remanufacturing, or recycling. So ultimately, one of the key goals of the circular economy is to optimize resource yield in both the technical and biological cycle at all times. Now, what is then circular economy and sustainability? What is the difference? Circular economy is closely intertwined with sustainability criteria, and it can be seen as a tool or practical framework to achieve sustainability objectives or sustainability goal. So circular economy evolved as an innovative paradigm that offer fast track towards a sustainable built environment. While sustainability encompasses a broad range of economical, environmental, and social objectives. So this is, I have already explained the meaning of sustainability. It's always often involves effective use of resources like energy, water, material, and also reducing waste, pollution, and ultimately protect the built environment. So now it clearly shows circular economy interconnects strongly with sustainability. And circular economy focuses more on optimizing the use of raw materials and offers a waste-free, resilient economic system. Promote sustainable construction through integrating uh, restorative and regenerative systems. So through circular economy, resources are kept in use for as long as possible and waste is minimized. We directly support the broader objectives of sustainability. If I ask a question, what factors are to be considered, right, when selecting building materials for a building? The common answer is what? Is cost. Yes. The common answer is the cost because it is important for the client. And also other common factors like strength, durability, availability, transport cost, easy of installation, aesthetic consideration also. But some smart clients, sometimes they look at maintenance cost, climate as resistant to fire, thus additional factors. Although construction industry is moving towards sustainable concepts, unfortunately, still less importance and less attention on sustainable aspects are paid by many stakeholders while developing design and also selecting materials. So how about, so these things, if I ask, energy content, raw material usage, depletion of material, like adaptability, recyclability, and disassembly, very rarely. So we should change our thinking pattern as a client, as a consultant, or as a developer. So this slide shows the findings of research done on design for circular economy. So their authors have identified 4 circular building principles. They are designing out waste, design for adaptability, selecting materials, and design for disassembly. Typically, we know that contemporary buildings are not designed for deconstruction. It means adaptability or disassembly, right? But circular economy building entails flexibility, adaptability, disassemble as its scope. Further, this figure illustrates factors to be considered under each principle. All are interconnected. Out of them, selecting materials will play a crucial role. Why? Because material will impact on the other 3 main principles to fulfill circular economy objectives. As discussed, circular economy is paid more on resource efficient and it is helping to protect natural resources. Right? So in a circular economy, waste does not exist. You know, consider waste as food. So therefore, durability and resilience are two features that need to be taken into account when selecting materials and components. So as explained here, circular economy is restorative and regenerative are main concept behind circular economy. And 3R, you know what is 3R? Reuse, reduced, and recycle are the common things we practice in the construction industry. 3R principles. Even under circular economy, 3R approach was recently expanded to include more action to transit from a linear economy to circular one. Hence, many R had been added in between. So you can here find the different R proposed by different authors in the literature with the eco-design term. So, simply circular economy incorporate principles of green practices and sustainability. And it is transition to a circular built environment is key to achieve a resource effective and sustainable society. It encourages the reduction of raw materials input, relies on renewable sources and eliminate waste from the system. So with the introduction of the circular economy, circular building or closed loop buildings as a have emerged as a practice that embodies every aspect of circular economy concepts. So these buildings, designed, planned, constructed, then operated, maintained, and eventually deconstructed in line with the circular economy principles. So this figure clearly illustrates the process of closing material and component loops in building. It also demonstrates how linear economic process can be transformed into a closed loop system. Because main feature of the circular economy is resources are viewed as scarce commodity. So as discussed, so in this slide, I just want to share some application of circular economy principles in material selection. So as discussed, when selecting building materials and components, it is important to look at their technical and biological cycle while thinking other factors. So CE encourage just use of recycled products and the recyclability of building materials and components at their end of life. And also construction and demolition waste are used to produce recycled materials. So one of the interesting study was here, bio-waste and agro-industrial waste also identified as a source for producing building materials such as brick, plasters, adhesives, particle boards, and thermal insulation materials. So many studies with the image of the circular economy, many studies have been conducted to evaluate the benefits of integrating concepts and principle integrating modular design of components, element, and adaptability. So this is one of the by using design, using deconstruction, the building designed for this assembly allows for reusing 63% of its mass. And accordingly, deconstruction and reuse enables saving up to 88% of carbon emission. So another case study on building insulation materials found that 40% of carbon emission can be reduced by adopting CE compared to the typical linear supply chain. So then in circular economy building design, selecting remade and bio-based materials for specific applications based on their properties and quality by keeping in mind the finite natural resources are paramount in. Now, this slide shows the benefits of implementing circular economy principles in material and component selection in building. So basically, you can see protect natural resources, virgin materials, then balance renewable resources and avoid unnecessary waste, because always waste does not exist with circular economy. Consider waste as food. And increase building flexibility and adaptability, that is the concept of deconstruction. So products are designed to be more durable, reduction in energy use and carbon emission. So all benefits stated here are important and ultimately create a sustainable built environment. Now, this slide shows the opportunities with implementing circular economy principles in material selection. First, new market for reusable building components. At the moment, we don't have a standard new market for the reusable building components. And also, design for the assembly and adaptability is another opportunity with implementing CE principles. So in the traditional method, right? So they have not incorporated those things. So with the CE concept, provide opportunity to adoption of eco-design, another implanting the off-site construction and modular construction. So another area is a supply chain. So rethink about construction supply chain. So there are new job opportunities and recognition for construction stakeholders. So they are right, a demolition and recycling business also have to change their perspective. Suppliers will become service providers, demolition business will become suppliers, right? Traders in building material become sector coordinators. So there are many opportunities with implementing CE principles in material selection. So in addition, we move with the digital technology and tools like a BIM, IoT, blockchain, big data, material passport, because with that, we need to track materials, then we have to record all these things. So we have to move with the digital technologies and tools. Another thing is sharing resources, especially the residue and byproduct between different sectors to industrial symbiosis. So industrial symbiosis refers the collaborative approach between the different industries. So there are, we can say, use of others' byproduct or waste or resources waste from one industrial process become a valuable resource for others. So these are the opportunities with implementing circular economic principle. Translating circular thinking to the building level might be challenging. So these are some of the challenges have identified by implementing circular economy principles in building materials and component selection. So technological limitation still as a developing country. So technology is a challenge. The quality of recycled product, I told, even though we have a more opportunity to build recyclable market, right? But at the moment, it's still the client, they're reluctant to deviate from their traditional method. So we should the problem with the quality of the recycled materials, no standardized building measures, right? And the lack of deconstruction information in building projects. And also, this is also very expensive process. So then financial support also the one of the challenges. And the most not important, even though I have mentioned at the lack of awareness of circular economic principles among our stakeholders. So now, so far we discussed benefits, opportunities, and challenges while implementing circular principle in building materials component selection. So this slide shows the strategies. So how to minimize, how to face those challenges, right? So we select the appropriate building materials and component at the early stage, because at the moment less attention has been paid. So the design towards adaptability and disassembly. So at the initial stage, because pre-contract stage may be the best place. If we go for circular economy while selecting building materials, even the design development, so we should think. An establishment of relevant requirements for waste and demolition plans guidelines. So at the moment we don't have. We have to have some standards to ensure quality and durability of the reuse and recyclable materials. Another strategy to implement CE principle is to development of recovery schemes and sharing information through industrial symbiosis. That is, I have already explained about the symbiosis. So we have to have a collaboration between other industries. Waste of one product, waste of one industry may be a resource for the another. And the last strategy, incentives for integrating CE principles. So the authority has a big responsibility for that. So finally, I would say the construction industry has the huge potential to implement circular economy principles. So adapting circular economy into the construction industry can promote the successful transition to sustainable construction. So positive mindset of all stakeholders, their collaboration and standardization are most important. And also, these are some of the research gaps I have identified. We need more research on sustainability manufacturing, recyclability materials, building deconstruction, life cycle assessment. So these are some future research directions. So I invite researchers to more research on these areas. So these are, I have come to the end of my presentation. These are some of the ongoing research projects related to circular economy. Advancing circular economy through strategic material selection in DFD, the case of doors and windows. And another important, we know slowly the industry is using bio-based material. So this is the high time to think, right? So this is another ongoing research with my undergraduate student. And another area I'm doing currently, deconstruction information model for design decision, integrating circular economy in built assets. So these are some of the references I have used to prepare this presentation. So this slide showcase this some research award I have received for my research work. With that, the conclude remark, each of us play the role, and together we have the power to shape the future. So thank you very much. Thank you for listening. Thank you very much. Have a nice day.
Professor K.G.A.S. Waidyasekara for your enlightening session on sustainable material selection in construction through the lens of circular economy principles. Your insights have truly enriched our gathering today. Now, I extend a heartfelt invitation to Professor Kanchana Pereira to present the lecture memento to Professor K.G.A.S. Waidyasekara. Many thanks to both Professor Kanchana Pereira and Professor K.G.A.S. Waidyasekara. Before we draw today's proceedings to an end, let's take a moment to express our appreciation to the sponsors of today's inaugural lecture. K.G.A.S Private Limited, our event sponsor. Daily FP, the print media sponsor. Sri Lankan Scientist, the social media sponsor. With that being said, we now conclude the 31st inaugural lecture organized by the Faculty of Graduate Studies at the University of Moratuwa. We deeply appreciate your presence today and look forward to welcoming you all back for our 32nd inaugural lecture as well. Thank you once again for your participation and have a wonderful day.